In multiple sclerosis, your body's immune system mistakenly attacks and damages nerves in the central nervous system, or CNS. The CNS consists of the brain, spinal cord, and optic nerves. A specialised membrane called the blood-brain barrier surrounds the CNS. Normally, the blood-brain barrier prevents large molecules, immune cells, and microorganisms circulating in the blood from entering the CNS. In MS, it is thought that immune cells, called T cells, become activated and migrate across the blood-brain barrier into the CNS, where they damage the myelin layer surrounding nerve cells. This causes disruption of nerve signals. In order to cross the blood-brain barrier, activated T cells must interact with the blood vessel cells that make up the blood-brain barrier. This happens when a protein called alpha-4 integrin on the surface of the T cell binds to a receptor on the blood vessel cells called VCAM1. This triggers the blood vessel wall to let the T cell cross into the CNS. It's a bit like the T cells have a key that fits a lock that opens a door in the blood-brain barrier, letting them pass through into the CNS. Tysabri is a medicine used for the treatment of relapsing remitting MS. Although the exact mechanism by which Tysabri works is not fully known, it appears to attach to the alpha-4 integrin proteins on T cells, which stops them from binding to the VCAM1 receptors on the blood vessel cells. In our lock and key analogy, it appears Tysabri clamps onto the end of the key, so it no longer fits the lock. This may help reduce the number of T cells that are able to enter the CNS and cause damage. This mechanism of action may help to explain how treatment with Tysabri may reduce the number of MS relapses you experience and help slow the progression of physical disability. Talk to your doctor if you have any further questions about MS or to learn more about Tysabri.